This topic will be a brief one, as there's not too much to cover, but it is both an important enough topic that it's essential to understand, and a general enough topic that it wouldn't make sense to squeeze in anywhere else. It deserves its own video. We are, of course, talking about scope. We've hinted at scope before, and you may have seen some of its effects in your own code. Maybe something didn't work the way you expected it to, or you got an error you didn't understand. Today we're going to break it down. We've already looked at flow control statements like ifs and loops, and we've looked at how we define functions. This means we should be familiar with the idea of blocks. To recap, blocks are the ways we separate out lines of code into groups. We need them for flow of control statements to work, otherwise we wouldn't know which lines of code were part of a statement's body and which were just at the root level of the code. We know that in Python, we open up a new block with a colon and indentation, that is white space to the left of each line, and it stays in that block until the indentation stops. We know that which block we're currently in depends on the amount or level of indentation. And we know that blocks can be nested inside of each other. So if block B is part of block A, then all the code inside block B is still also technically in block A. In programming, scope has got everything to do with what code is in which block. What is scope? In short, scope is about how long Python stores things in memory. In Python, the scope of any definition, that is functions, variables, and classes, which we'll get to later, is determined by which block it first appears in. This is easiest to see at the base or root level. Any statements written outside of any blocks, that is no indentation, are said to be global, and will be accessible from anywhere in the program. See how we are still able to reference the global variable myvar from inside a function block. That function, foo, is also global, so we can call it from anywhere else in the program. Now let's look at another example. We're going to define a new function, and we're going to declare a variable inside it. Watch what happens when we try to reference that variable outside of the function. We get an error, telling us that basvar is not defined, but surely it must be. We declared it earlier, and we were able to reference it again okay at least once inside the function. So why is it a problem now? This is because basvar is not global. We define it in baz, which means that it can only be used inside baz. It's a local variable. Once the program exits or returns out of a function, all local variables are cleared. The program sort of forgets them because it assumes that they're no longer needed. By the time the program we just looked at gets to line 8, the problem line, basvar is gone. It only ever existed in the scope of baz. So why does Python do this? Well, there are a few reasons. The main one is to save space and stop programs taking up too much memory when they run. After all those variables and function definitions do need to be stored somewhere. As programs can grow to be very large, with potentially hundreds of functions and thousands of variables, can you imagine if the computer had to hold on to all of them at once? Much better to only load them when they're needed, and then clear them away once they're not. The second is neatness. Variables being local to the scope of a function means that multiple variables in different scopes can share the same name, without having to worry about one overriding the other. It also just encourages good practice when designing and writing your code. Take a look at this. You might have been expecting it to print out buzz. After all, we called the function updateStore to change the value of our variable to buzz. So why is it back to fizz again? Sure, if we remove that top line, store would become a local variable, and we'd get an error if we tried to reference it out of scope. But surely, because store is global, it should work fine. Well, no. You can access variables from a higher scope, and you can do certain operations to them, like alter them, so that's things like adding elements to a list or values to a dictionary, but what you can't do is completely replace or redefine them. This means that for our immutable data types, the ones that can't be changed, like strings, booleans, and numbers, we can't change them at all. We can try, we won't get an error, but it will be treated like a new variable in memory. A new variable which will of course eventually be cleared away, fall out of scope, in favour of the old one. So far as the computer is concerned, what we've actually done is define a new local variable, one which coincidentally shares the same name as the global one, but it's not the same. But what if we did need to replace a global variable at the local level? Well, generally speaking, we don't. If a function is intended to override a variable, it's much more common to have it return that value so it can be assigned at the right scope. But if we really want to, we can use the global keyword. This specifies that we're interested in the global property of that name, or forces that property up to the global scope if it wasn't already. Although, overusing this feature, or really using it at all when it isn't completely necessary, is generally considered a bad habit, as it can lead to some pretty messy code. By all means, have a play around with it and see how it works, but try not to rely on it. What about if, else, and loops? Do flow control statements have their own local scopes too? After all, they use code blocks just like function definitions. Well, actually no. In some languages, like Java, this is the case, but Python only scopes objects inside of functions and classes. But a lot of the time, it's a good idea to write your code as if they do. Remember that the whole point of flow control statements is that they're flexible. They can run as you need, as many times as you want, or even not at all. If your if statement is meant to do something important, like define some variable that you end up referencing later, and that if statement ends up not running, you're kind of stuck. Better to define them before, with some placeholder or default value just in case. This all works the way it does to help programs scale better as they get larger and start taking up more memory. Understanding scope is vital to making sure your code will behave the way you expect it to. Ideally, if we've designed our code right, none of this should ever be a problem. But of course, we all get caught out occasionally. But the more practice we get, the better.